RL and RC transients. Okay, by using PSpice, so we have to execute so RL and RC transient analysis. So by taking one simple RL circuit, time domain analysis of a series RL circuit, one type of RL circuit. Similarly, time domain analysis of series RL circuit. So by using PSpice, we have to verify the results. Okay, this example, the circuit shown in figure, this HS has been closed for a long time, then opens at t is equal 0. So this circuit switch S has closed for a long time and is opened at t is equal 0. So at t is equal 0, the circuit is open and is closed for a long time. Okay. So this is the circuit. This is called one DC voltage source and is having resistance 10 ohms and 6 ohms. And this is resistance 5 ohms and inductance 1 8. A circuit is connected in between these two, this switch, and the current flow into the 5 ohm resistor is called Ix of t. So for this question, so VAB of 0 minus. So VAB of 0 minus means voltage across the inductor. Voltage across the inductor before switching actions. So at t less than 0, the switch is under closed. T less than 0, t is under closed condition. T greater than 0 or t is equal to 0, switch is open. Okay, fine. And then at x of 0 minus also, so that means under switch is closed condition. Under switch is closed conditions, we have to find the current flow into the this resistance. And similarly, Ix of 0 plus, just instant of switching action, just after switch is open, then we have to find this current flow into the 5 ohm resistor. That is called Ix of 0 plus. And then next VAB of 0 plus means just instant of after switching action, that means just instant of switch is open, then what is the voltage across the inductor. And then similarly Ix, the current flow into the 5 ohm resistor at a t is equal to infinity. Okay, that means under steady state condition, that means under switch is opened for a long time. After that, we have to find the current flow into the 5 ohm resistor. Under steady state condition, in the inductor acts as a short circuit. And the next VAB, that is called voltage across the inductor at a t is equal to infinity. So that is under steady state condition, what is the voltage across the inductor. And then next expression, Ix of t, current expression. So by finding the current expressions, we have to verify this theoretical expression. We have to verify in practical PSpice simulation. So before going to execute this experiment, first we have to find the theoretical calculations. So what is meant by VAB of 0 minus? So VAB of 0 minus means so voltage across the inductor. So voltage across the inductor VAB of 0 minus. So at t is equal to 0, this switch is open. At t is equal to greater than 0, also switch is open. But t less than 0, switch is under closed condition. This is also one type of steady state. So because of this, inductor short circuit. Before switching action, the inductor acts as a open short circuit. Okay. Before switching action, that means t less than 0, inductor under steady state condition, that's why it acts as a short circuit. Okay, and then voltage across the inductor is equal to 0. So when the switch was in closed position for a long time, the circuit is reached in steady state condition, that is current through the inductor is constant, and hence the voltage across the inductor terminals A and B is equal to 0. In other words, inductor acts as a short circuit. That's why, so voltage across the inductor is equal to 0. Okay, and it can be seen that there is no current flowing through the 6 ohm resistor. So during short circuit condition, and also the switch is closed condition, the switch is closed and also it is short circuit, and then the current, whatever the current supplied by the source, this current and is leaving from the 10 ohm resistor in this way. Current is always choosing low resistance path. So it is short circuit means whatever the current supplied by the source is flowing in this direction. okay, and also into the direction, but not flow into the current flow into the 6 ohm resistor. That's why 6 ohm resistor is invalid. Understood? So it can be seen that no current flowing through the 6 ohm resistor. The following are current through the different branches just before the switching action. Okay, before switching action, t less than 0, switch is closed condition. T less than 0, switch is under closed condition. Then what happen? Ix of 0 minus is nothing but this Ix of 0 minus. So this current flowing to the 5 ohm resistor is nothing but, so it is invalid. No current flowing to the 6 ohm resistor because of this short circuit, and also switch is closed. And then these 10 ohm resistor and 5 ohm resistors becomes parallel, and 20 by 5 is called 4 amps current. Then Ix of 0 minus is called 20 by 5, that is equal to 4 amps. And the current through the 10 ohm resistor is called 20 by this 20 voltage by this is parallel. So 20 by 10, that is called 2 amps. So current flow into the 10 ohm resistor is called 20 by 10, that is equal to 2 amps. And then the algebraic sum of these two currents is nothing but current flowing to the inductor. So this current and this current. Current flowing to the 10 ohm resistor is called 20 by 10, and the current flowing to the 5 ohm resistor is called 20 by 5. So 4 plus 2, that is called current flowing to the inductor. So before switching action, that is called under before switching action, that is called t less than 0, switch is under closed condition. Then current flowing to the inductor is nothing but 4 plus 2, 6 amps. IL of 0 minus is equal to 6 amps. So this is the condition before switching action, and next after the switch open condition, that is called t is equal to 0 plus at t greater than 0 or t is equal to 0. That means t is equal to 0 plus means just instant of after switching action, that is called switch is open. At t is equal to 0, switch is open means at t is equal to 0 plus also switch is open condition. So for this instant, so what is the current flowing to the different branches we have to find. So the current through the inductor at t is equal to 0 plus is same as that of IL of 0 minus, because of inductor does not allow sudden changes in current. That's why IL of 0 minus is equal to IL of 0 plus. Since inductor cannot change the current suddenly, instantaneously. So therefore current through the X of 0 plus is given by X of 0 plus is equal to IL of 0 plus is equal to 6 amps. So previous condition, the current flow into the so inductor, that is called IL of 0 minus is equal to 6 amps, and this is open, switch is open. That's why this 5 ohm resistor and this inductor both are connected in series. That's why current Ix of 0 minus is nothing but 6 amps, that is equal to IL of 0 minus. IL of 0 plus, IL of 0 plus. Just after the switching action, whatever the current, before switching action, the current across the current flow into the inductor is nothing but IL of 0 minus is called 6 amps. So at t is equal to 0 plus, just instant of switching action, inductors does not allow sudden changes in current. Okay, that's why this 5 ohm resistor and this inductor is connected in series. That's why, so whatever the current flowing to the inductor is same as current flowing to the resistor. After switching action, that is called IL of 0 plus is equal to IL X of 0 plus. Understood? So IL of X of 0 plus is equal to IL of 0 plus is equal, that is equal to 6 amps. So then by applying KVL around the closed loop at t is equal to 0 plus, we will get in this is called open. So here we have to apply the KVL equation. Then we will get, so in this way, applying KVL around the closed loop at t is equal to 0 plus, then 20, that is nothing but here what is the voltage? 20 volts. Here minus, here minus, here plus, here plus is connected here. Plus this plus is connected to the this terminal, and the plus minus is connected to this terminal. That is nothing but the voltage across the 10 ohm and 6 ohm is nothing but this branch is called 20 volts. This is open circuit. That's why these two are series, and this connected to parallel to 20 voltage source. So that is why this voltage across these two resistors is nothing but 20 volts. So that's why that is nothing but here, right here, like the 20 and the Ix of 0 plus into R, Ix of 0 plus into R, and then voltage across this here, X of 0 plus into R, that is equal to VAB of 0 plus. That is called voltage across the inductor just instant of switching action. And then 20 minus X of 0 plus is called 6 amps. Substitute here, and then it is equal to VAB of 0 plus is equal to minus 10 volts. Okay. So after switching action, just instant of switching action, the voltage across the inductor is called minus 10 volts and is negative. So the negative sign indicates that inductor terminus B has positive terminal and it acts as a source of energy. So mathematically, we can written as VBA of 0 plus is equal to 10 volts. So minus 10 volts means the voltage across the here 20 volts, but this voltage across the inductor is called minus 10 volts. That means extra 10 volts present across the inductor. So that's why it acts as a source, energy source is device. It acts as a source. Okay. So that's why VAB of 0 plus is called minus 10 volts. And then next is under steady state condition is called a t is equal to infinity. So under infinity condition, inductor acts as a short circuit. At steady state condition, t is equal to infinity, current through the inductor is constant, and inductor acts as a short circuit. So this establishes the following relations at VBA is equal to t is equal to infinity. So obviously, if the whole inductor is short circuit, means voltage across the inductor is also zero. Then Ix is equal to, at t is equal to infinity. So under infinity condition, so this switch is open and this is called a short circuit. Then voltage across this resistor is called 20 and 20 by 5 is called 4 amps like this. X is of t is equal to infinity. Then the steady state condition current flowing to the 5 ohm resistor is called 20 by 5 that is equal to 4 amps. And then so by writing the KVL equation, okay, so we can written as like Vs minus Ix of t into 5 minus L into dx of t by dt is equal to 0. Okay, for the circuit Ix of t for t is greater than or equal to 0. So obtaining KVL around the closed path. Okay, so this is the expression. X of t is equal to a1 into e power minus r by l into t plus a. This is called transient condition and this is called steady state condition. Under transient condition, this is the expression. Under steady state condition, this is the expression. And then at t is equal to 0, Ix of 0 is equal to IL of 0 is equal to IL of 0 plus is equal to 6 amps. Initial and final conditions. And then at t is equal to infinity, inductor through the inductor is called IL of t is equal to infinity is called 4 amps. Under steady state condition, inductor is a short circuit. The current flowing to the inductor is called 4 amps. That is called 20 by 5. Okay, so 4 amps. Using initial and final conditions, we get a1 is equal to 6 minus a and a is equal to 4 and a1 is equal to 2. Okay, and then final expression, we get final expression x of t is equal to 4 plus 2 into e power minus 5 to t for t greater than or equal to 0. So this type of expression, so we have to verify by using p-spice. So okay, so then go for this circuit, for design of the circuit for by using p-spice. It's clear. And open schematic p-spice. Open schematic. So like this, open p-spice schematic, and then first DC voltage source. Take one VDC, place here, and similarly two resistors. Take two resistors, rotate controller, place here, and next here also place one inductor also, resistor and inductor. Resistor, place controller, place here, and take one inductor, place here, controller like this, and take one switch. Switch that is called open switch. Open switch. Switch is open. So place in between these two. Okay. So in the circuit, so 20 voltages, 10 ohm, 10 ohms, 6 ohms, and R is equal to resistance 5 and L is equal to switch, open switch. Okay, these are the circuit elements we have to take. So connect these all elements by using this wire. Connect here. This way. This fashion. And also this resistor here. Connect here. Secondary side. and connect in this way, switch to here and also here. So this is the connection, and take one ground, the ground place here, and then we have to change the voltage of the source. See here, voltage is called DC voltage 20 volts. Save. Okay. And here, what is the resistance? So value is called 10 ohms. 10 ohms. Save alter, then okay. So next resistance is called 6 ohms. Here change value of resistance is equal to 6 ohms. Then similarly, R is equal to 5 ohms. Value of R is called 5 ohms. And then next inductor is called how much inductance? 1 Henry. Inductance value 1 Henry. 1 Henry. Save alter and then okay. So everything is fine. So resistance 10 ohms and 6 ohms, and R is equal to 5 ohms and L is equal to 1 Henry. This called voltage across the inductor. Okay. So then here, what is the time constant here in the circuit for this expression? Ix of t is equal to 4 plus 2 into e power minus t by tau. Tau is called 1 by 5 e power minus t by tau. That is called time constant is equal to 1 by 5. So 1 by 5 means 0.2 seconds. So steady state time is called 5 into t, 5 time constant. That's why 0.2 into 5. So how much? 1 second. So take final time is called greater than 1 second. Go to analysis, setup, and enable transient, and transient press transient. Here, what is the time? So final steady state time is called 1 second. That's why take 2 seconds. It's clear? And then okay, close and save. So transients RL circuit. Then so we have to verify this expression. Ix of t is equal to, so what is this expression here? Ix of t is equal to 4 plus 2 into e power minus 5 by 1 minus 5 into t. So here under this is called steady state. Under steady state, the current flowing to the 5 ohm resistor, that is called Ix of t. Under steady state and t is equal to infinity, that is called Ix of infinity is called 4 amps. And t is equal to 0, t is equal to 0, e power 0, 1, that's why 4 plus 2, that is called 6 amps. So by connecting one probe here across resistor, so because of this Ix of t is called what is the Ix of t? Current flowing through the here 5 ohm resistor. That's why connect one current probe here across the resistor. Okay, in the schematic. So take one current probe I, connect here. Okay, fine. Like this. And then simulate. So it's taking some time. Simulate, and then it's new pop up. So what is the current here in this waveform? This expression. So what is the current here? Current means 6 amps. So at t is equal to 0, in this expression, x of t is equal to 4 plus 2 into e power minus 5 by 1 into t. So t is equal to 0, 4 plus 2 is called 6. That's why at t is equal to 0, the waveform will start from, at t is equal to 0, the waveform starts from 6 amps onwards. So these are the initial conditions in the capacitor, in the inductor. IL of 0 minus IL of 0 plus is equal to IL of 0 minus equal to 6 amps. So under steady state condition, that is nothing but a t is equal to infinity. At a t is equal to infinity, this term will become 0, and the x of t is equal to infinity is nothing but 4 amps. The final steady state current is called 4 amps. So here this is called 4 amps. This finally the current across the resistor settled at 4 amps only. This is called x-axis. For 4 amps, the current is equal to, so for 4 amps, this at t is equal to infinity, this is called current. Okay, and at t is equal to 0, the current is called 6 amps. X of 0 is called 6 amps, and X of infinity is called 4 amps. So like this, we have to verify, and also, so we have to verify that is called voltage across the inductor. So by taking markers, mark voltage difference. Okay. Under steady state condition, what is the voltage across the inductor? 0, because of its short circuit. So connect one voltage marker difference here, and then simulate. Then waveform is like this. Width, change width. So this voltage across the inductor is nothing but minus 10 volts. That's why here minus 10 onwards. And then at t is equal to 0, that is at t is equal to infinity. Under infinity is nothing but under short circuit condition. That's why the voltage across the inductor is equal to 0. At t is equal to infinity is equal to 0. The voltage across the inductor, this is called voltage waveform across the inductor. So voltage across the inductor is equal to 0. So this is called 0, 0 axis. Here minus 10 volts. So, okay, that means inductor voltage across the inductor is nothing but minus 10 volts. Minus 10 volts onwards is the voltage decreases, and then under steady state condition, that is a short circuit. Under short circuit condition, the voltage is equal to 0. Okay, so like this, we have to verify transient analysis of series RL circuit for this example.